All right, I am making this video as just a help video as I'm grading the 3.12 unit test part 2s. And so this way I can send it out. And if you miss number 1, I could say watch number 1 on this video for some help, watch number 2, watch number 3, and so on. So number 1 is asking us to factor the expression x to the 6 minus 729. And it says show your work for full credit. So the thing about number 1 is x to the 6, that exponent is divisible by 2, which makes x to the 6th a perfect square. And 6 is also divisible by 3. So that makes x to the 6th a perfect cube. So I have a problem where x to the 6 is a perfect square and a perfect cube. Same thing with 729. 729, if we took the square root of 729, that's pretty big. I don't know that, but I'll do it really quick. The square root of 729 is 27. So 27 times itself 2 times is 729. And then I can also take the cube root of 729. And the cube root of 729 is 9. So what I have for number 1 is I have 2 terms that are both perfect squares and perfect cubes. So I'm not sure if you remember this in your OHS, but if you're asked to factor and you have something that's both the difference of squares and the difference of cubes, you're going to start using the formula for the difference of squares. Okay, and this is why. If you start with the difference of cubes, you're not going to be able to factor completely. So we always teach you to start with the difference of squares. So I've made a different problem up. It's similar to the first one. X to the 6 is a perfect square and a perfect cube, and so is 64. So I'm going to start, okay? So step number 1, I'm going to start with treating this like it's the difference of squares. So that means I'm going to need to know my A, and I'm going to need to know my B. So my A is going to be the square root of x to the 6th. So what times itself 2 times is x to the 6th. That's going to be x to the 3rd. And then my B is going to be the square root of 64, which is going to be 8. And then I'm going to use my formula, which says A plus B times A minus B. I've got all my formulas written over here. So if I've got this one wrong, hold on. This is supposed to be minus. Okay. My A is x cubed, my B is 8. So I'm going to plug that in. So I'm going to do A plus B. So that's going to be x cubed plus 8. And then A minus B, that's going to be x cubed minus B. Not minus B, minus 8. So start the problem using the formula for the differences of squares. Number 2, now we're left with step 2, we're left with x cubed plus 8, which is the sum of cubes. So we'll use the formula there. And then I've got x cubed minus 8, which is the difference of cubes. And then I've got a formula for that. Okay, so I am going to have to determine my A and my B. For both of these, A is going to be x, B is going to be 2. Because you're doing the cube root of x cubed to get your A, the cube root of 8 to get your B. Same thing's going to be here. The cube root of x cubed is going to be x. So x is going to be A. The cube root of 8 is going to be 2. So B is going to be 2. And then we're going to use, this is the sum of cubes. I'll do this one in blue. So I'm using this formula for the sum of cubes. So it's going to be A plus B. So that's going to be x plus 2. And then I'm following the formula A squared. So that's going to be x squared minus A times B. So that's going to be minus x times 2. That's 2x plus B squared. So plus 2 squared, which is 4. So that's going to be how I factor x cubed plus 8. Then I'm going to switch to x cubed minus 8. So let's swap colors there. Let's do purple. X cubed minus 8. So I'm going to be using this formula. So I'm going to do a minus b. That's going to give me x minus 2. Then I'm going to do a squared. So that's x squared, which is x squared. Then plus a times b. So plus x times 2, which is 2x. And then plus b squared. So it's going to be plus 2 squared, which is 4. So we end up with 1, 2, 3, 4 factors. And that's how we're going to get that problem to factor completely. All right, so let's talk about this. Step number 1, we started with the differences of squares. So when we have something that's the difference of squares and the difference of cubes, if we want to get it factored completely, and that's what they're asking us to do, we're always going to start with the difference of squares. Once we do that in our second step, we ended up with a sum of cubes times a difference of cubes. And those two will factor using our formula for the sum of cubes and then using the formula for the difference of cubes. All right, hopefully that'll be helpful for number 1. For number 2, I'm not gonna really work one of these out. I'm gonna suggest that you go back to section 3.08. And I'm going to point out that this is not asking you to solve by factoring. It's asking you to solve by something called completing the square. So that was taught in section 3.08 in your OHS. So I'm going to suggest my hint for this one is to go back and look at some example problems in section 3.08. If you don't want to do that, then you can just Google an example of how to solve a quadratic using completing the square. But you are going to have to use this method, not factoring, not quadratic formula. You're going to have to use this method in order to get full points for number 2. All right, number 3 is asking us to factor over the set of complex numbers. So this is something I mentioned today in Class Connect. When it's talking about complex numbers, that means imaginary numbers. So I did make up an example. Goodness gracious, it's been a long day. I did make up an example for number 3, and I have it written down. It is x to the 4th minus 7x squared minus 144. So again, because the directions say factor over the set of complex numbers and show your work, because it says complex numbers, that means imaginary numbers, and you're going to need to know that as you work the problem. So I have 1, 2, 3 terms. That's a trinomial. We always try to factor our trinomial into 2 binomials. My last term is negative. That means my signs are different. So I'm going to do plus minus. Now, I do have an x to the 4th here. Usually, not always, but usually I have an x squared. So I do an x times an x. But because I have that x to the 4th, I do have to do x squared times x squared. And then 144 is a really big number. So I honestly don't know all the factors of 144. So I would ask my handy dandy calculator to help me out here. So I'm going to do 144 divided by 2, and so 2 times 72 would be factors. I don't think 3 is going to go into 144. Oh, it does. I don't know a whole lot about all the factors of 144, so I know 5 is not going to go into 144. Hold on a second. Not right now. No, give me about 5 minutes, Ramus. I'm in the middle of making a video. Give me 5 backyard, but y'all got to be quiet. Sorry about that. 12-year-old grandson wanted to invite some friends over. No. How about the backyard? Sure. Okay, 6 times 24. Will 7 go into that? No. Will 8 go into that? Yes. 8 times 18. Now, the good thing is you've got a 36. Okay, so mine actually is a little bit harder than yours. So I know if you're thinking, woe is me. What about 9? Gosh, I had no idea 144 had so many factors. All right, it's actually going to be 9 and 16, so I'm going to stop. I need two things that multiply to be negative 144. So it's going to end up being 9 and 16. And let me show you how we're going to get this negative 7. Remember, we multiply our inside terms. That's going to give me positive 9x squared. We multiply our outside terms. That's going to give me negative 16x squared. And then those two terms combine to be that negative 7x squared. Okay, now I'm just going to go ahead and write those factors down again, since I showed you how we know they multiply back together. Okay, so we're still factoring. Okay, we have these two factors. X squared plus 9 is the sum of squares, and x squared minus 16 is the difference of squares. Because they told me we were factoring over complex numbers, then I know instead of saying x squared plus 9 is prime, because we do say that, okay, I have said it before, if we have the sum of squares, I've told you that that is prime. If they tell me that I can use imaginary numbers, then I have a formula for factoring the sum of squares. It's a plus bi times a minus bi. So because they've said complex numbers, then I'm going to use my formula, a plus bi times a minus bi. And then the differences of squares has the formula a plus b times a minus b. So for x squared plus 9, a is going to be the square root of x squared, which is x. B is going to be the square root of 9, which is 3. For my x squared minus 16, a is going to be the square root of x squared, which is x. B is going to be the square root of 16, which is 4. So then I'm plugging into these two formulas. So for the x squared plus 9, my formula is a plus bi times a minus bi. So that's going to be x plus 3i as a factor, x minus 3i as a factor. Then I'm going to factor in my x squared minus 16. That's going to be a plus b. Here's my a, here's my b. So that's going to be x plus 4 times a minus b, which is going to be x minus 4. So you're going to end up with 3 factors. And that's going to be how you factor completely over the set of complex numbers. Hopefully this was helpful. I will send this out as I grade your Unit 3, Part 2, just as a way to get some information to you to help you get through making some corrections.